saw how to do this before. The first step is to multiply the top row by 3 and the bottom by 2. So that gives 3 times 2 is 6, 3, 3, 0, 6, 8, 0, 2. And then we took row 2 and subtracted row 1. Okay, so top row stays the same. Okay, we get 0. 8 minus 3 is 5. 0 minus 3 is negative 3. And 2 minus 0 is... Okay. Next, what we want to do is clear this 3. So as we saw before, what we did first was divide the second row by 5 to make this a 1. So we'll do the same thing here. 6, 3, 3, 0, 0, 1. We're dividing everything by 5 in the second row. Okay, so we're getting some fractions now. And I'm just going to continue, again, assuming you're somewhat familiar with row operations. Okay, so next we take row 1 and subtract 3 times row 2 in order to get rid of this 3 up here. Okay, we get 6, 0. Then we get 3 minus 3 times this. So that's going to be 3 plus 9 over 5. I'm going to work that fraction out in a minute. And then we get 0 minus 3 of that. So that's minus 6 over 5 here. Okay, and then this row stays the same. Okay, I want to write this as a fraction. That's 24 over 5. Okay, 24 over 5. Okay, let me squeeze it in there. 24 over 5 on top. And then we're almost done. Let me erase what's down here. We want the identity matrix on the left-hand side of this bar, so we need to divide the top row by 6. Okay, so again, giving us 1, 0. Dividing by 6, so that'll cancel a common factor with that 24. It'll leave a 4 on top. Okay, and then again, canceling factors. That makes this negative 1 over 5. We have 0, 1. So we just divided this top row by 6 here. Negative 3 over 5 and 2 over 5. What does this tell us? What this tells us is the inverse. This equals A inverse. Okay, I haven't shown you exactly why that's the case, but the general idea is that the row operations that take A to the identity matrix take the identity matrix to the inverse of A. Okay, and I can show this explicitly in another video. This isn't the place, but you can take it for granted that if you follow this procedure correctly, you'll get the inverse of A. So what did we have before? Let me copy down exactly what this inverse matrix is. We have A inverse equals 4 over 5, negative 1 over 5, negative 3 over 5, and 2 over 5. Okay, so I can now erase this. Okay, and going back to what I said before, A inverse has the property that it can give you the solution set X as follows. Okay, this was explained a little while ago. Okay, so what's this going to be? It's a matter of matrix multiplication. This times 5, 15. Okay, assuming you're familiar with matrix multiplication, what does this give? 4 over 5 times 5 gives you 4. So it's 4. And then minus 1/5 times 15 is minus 3. Okay, that's in the first entry. Then down here, negative 3 over 5 times 5 is negative 3. And then 2 over 5 times 15 is 6. Okay, and what we end up with is that this is equal to, push this up a little so we can see the solution, which we already know is 1, 3. Okay, so we saw 3 different ways to get the solution of, okay, so again, the solution of a system of equations. This says x equals 1 and y equals 3, as we know. Okay, we saw how to do it using the method we learned in high school, which is substitution. So that gave us the solution, and then we saw 2 more, let's say, sophisticated methods, both essentially using row reduction. The second one introducing this idea of the inverse of a matrix.